Good morning, good afternoon, good evening, wherever you are, and welcome back to another episode of The Ways We Move, the podcast that highlights innovative mobility solutions and the people behind them. My name is Nicolas Zart, and I am your host on this podcast. And if you can see the grin I have on my face, it's because, sorry for those of you who are only listening, you can watch me on YouTube and other, I think Spotify now does it, and Apple Podcasts will have the video very soon. But I have a grin because I finally got to bring on this podcast somebody I've admired for so long, for, well, almost 20 years now. Someone who is probably the quintessential British gentleman, does not speak very loudly of himself, and yet everybody who drives a Tesla, who drives a Lucid, who likes any kind of modern electric vehicles, EVs, should know about, and that's David Moseley. The same kind of question I'd like to ask you guys. Do you know who designed the Jaguar E-Type? It's everybody knows, almost everybody knows what the Jaguar E-Type is. It's so beautiful, it's so amazing. We all know it's a Jaguar, but do you know who the designer is? Or was, I should say? Well, that's Malcolm Sayer, and he was an amazing also designer who just, kept it very quiet and modest and humble. David is exactly forged within the same forge, I guess, or the same template as that. David is a physicist that was brought on by Peter Rawlinson at Tesla when they were designing the Model S, which wasn't called the Model S at the time, but White Star. And it was amazing because David was brought in to help with the crash test ratings. And if you know anything about the Model S, well, you know that you might even remember that Elon Musk said it had 5.5 star ratings, which of course does not exist, but it did surpass any expectations, better than a Mercedes, better than a Volvo. And that's something a lot of people forget. In this podcast, we get to understand why the Model S was so well built and can withstand some serious accidents. And that's because they had to start from scratch. They couldn't just use a chassis from one of the big five chassis makers in the world. And then instead of a internal combustion engines with opposing pistons, they had to design a car that was designed first and foremost as an electric car with an electric motor, or two or three in some cases, and a battery pack, which means the crash zones, the crumple zones had to be thought of completely new. And this is where David steps in. Well, after the Model S, Peter Rawlinson wanted to do his second chef-d'oeuvre, and that's Lucid Motors. Now, of course, he started Ativa first, and that got into Formula E. But then Lucid Motors designed what I think is probably the best EV you can get right now, and that's the Lucid Air. And this is where we met David Moseley in 2017 with Peter Rawlinson at the Peterson Museum in Los Angeles. And this is where we got to see for the first time the Lucid Air. And you can go and look at it on Clean Technica. You'll see my article. It's a really pretty picture of the car. It's in black and white because it was just stunningly beautiful like that. And in for this article, we got to go up the spiral ramp of the garage of the parking lot of the Peterson Museum. We were probably hitting 20, maybe even a little bit over 20 miles per hour going up, not brutalized. The car made an everlasting impression on me. And of course, David worked his magic there from then on. I also saw David later on in an amazing company called Byton, which sadly should have made it, did not make it, the alias of the startup world. And then after that, well, he is back in England, and now he's helping the local bike shop repair things. I just love David. I've wanted to have him on the podcast for so long. And that's why I have that smile on my face, because he will have to come back. Because you know why? 15 minutes into our discussion, I wasn't even following the ideas and the thoughts and the questions that I had forgotten. And I look at the time and I'm thinking, oh my, it's already 15 minutes. I just need to ask you a quick question about you, but you have to come back. So in about a month or so, David will come back and we'll continue the discussion into other parts of the electrified mobility segment. But I hope you enjoy this, because I certainly have. David should be a name that's etched in your mind when you drive a proper modern EV that's designed from the bottom up, an EV that was designed to be an EV, not a gasoline car that happens to have an electric motor, which is pretty much 90% of all the EVs out there. Only a handful of companies can do that. And so I hope you will remember the name David Moseley, because he is just absolutely amazing person and someone I'm very, very fortunate to call a friend. As always, please like, please subscribe. That really means a lot to us. It helps us get up there in the ratings. And of course, share if you know of anyone who's interested in these innovative mobility solutions and who are the people behind. And if it motivates maybe your children to take up a career in this absolutely fantastic, well, these fantastic industries, I should say. And of course, if you want to have access a little bit earlier than most people, go and see our Patreon site. So it's patreon.com/tap, not Taposaurus, that was my other one, patreon.com/the ways we move, and you will see different tiers where you can either access 48 hours early and another tier where you can get down into the details where I do at least one deep dive a month and behind the scenes that you will never see anywhere else. We need your support, so we would love to see that happening. This is the second year. It's been actually a year and a quarter for the ways we move, and we want to continue it like that. So we need your support. So thank you, Patreon supporters. In the meantime, please enjoy David. I had a terrific time speaking to David, and I look forward to having him back again. Thank you all. David, welcome to The Ways We Move, the podcast where we talk about innovative mobility solutions and the people behind them. I can't tell you how long I've been wanting to have you on this podcast, because just to have your experience and expertise on anything electric mobility is just something I've always wanted to do that. So welcome to the show. How are you doing today?
Yeah, very well, thank you. It's great to be here. I'd love to participate in chatting. That's one of the great things about being old, Nicholas. You just have a long list of stories and a declining audience of people to tell them to.
Well, I want to make sure everybody does listen to your story, because you've got some really fascinating stories. By the way, I'm writing a book, and you're going to be quoted in it, and I hope you will edit some of it so I don't misquote you. But yeah, there's a lot to say, and you certainly were, at a key moment of the going into the electric mobility revolution. But before we start to talk about that, let's start with the basics. Tell us a little bit about who is David?
Well, you probably guessed from my accent that I'm not from over that side of the Atlantic. So I started off my working career as a physicist and then an automotive engineer in the UK, and working for companies like Lotus, for example, and various suppliers. I met a guy, a friend of mine at Lotus, who moved on to Tesla, and at the beginning of the Model S program, he invited me out there to work on crashworthiness and structure. I was a simulation and optimization engineer, really, and I'd never had any contact with electric vehicles before the beginning of that Model S program. And I just fell in love with the concept, the technology. It just seems such an elegant way of providing automotive powertrain. It's a well-known thing. Many people have said it before me. But if you were to actually design the perfect torque speed curve for a car, the torque speed curve you would drive is basically an electric motor. It's just a flat torque as long as the motor can sustain it. Practically, it's just the thing that you want for a car. And then when you combine that with, I think the ecology arguments are important, and they're going to be increasingly important as the world develops. I just think there's a very, very strong argument in favour of battery electric vehicles from an ecological perspective. So I decided not to move out to LA, which is where Tesla was at the time, and I didn't particularly like the city, so I did some contract work for Tesla then back in the UK. But I decided that EVs, that is where I wanted to be. And as soon as I got the opportunity then to come back out to California to work on the next project, which was the Lucid Air, as it turned out, that was, I leapt at that opportunity and at the opportunity to transfer from structural and crashworthiness into powertrain concepts, and that was really also the start of my involvement in powertrain. So yeah, that's in a nutshell how I got to be there. But because I'm a physicist, I have a different bag of tools to the bag of tools that proper engineers have. So obviously it's just between you and I that I'm not really an engineer, I'm just bluffing, so don't tell anybody. But it does mean that I've got I've got some different mathematical techniques and so on, which are less common in the engineering thing. And obviously I can ask proper engineers about all the stuff I need to know from there. So that was an advantage to me, I think, in getting involved, particularly in the optimization side of automotive design.
Wow, yeah, that's a very good point. And I think that's one of the greatest thing about the electric mobility industries is the brain share that were brought in from different parts of not necessarily the automotive world. And I think we could say that the person who invited you to Tesla was Peter Rawlinson, who is
Yeah.
also another brilliant guy who designed the Model S and then later on went on to create Ativa and then Lucid Motors. And of course, to this day, honestly, my three favorite cars are, well, by far the Lucid Air. I mean, that is just a given. But the Model S and the Model 3 is just fantastic also. So to know that
Yeah.
that your DNA is in there is always always smile when I think of that.
Yeah.
You once told me a story and it kind of stuck to me, and I just want to confirm if that's true or not. When you guys were working on the Model S in the very beginning, so yeah, Peter was designing the entire car, then you started to go into the crash worthiness and all that good stuff. But at one point or another, I think you told me that Elon Musk told you, well, you guys now need to go out and find who are the battery experts, who are the electric motor experts and everything. And then you said something to the extent of, we went out for 2 weeks, there are none. And then Elon Musk said, well, now you are. Is that more or less true, or did I completely imagine this one?
I hope I never said that because I don't think that's true. Maybe there was a time when I believed that. But actually, funnily enough, Elon did have, there were a lot of the powertrain side of the Model S was a kind of a different part of the company. And I don't think they were particularly automotive savvy people. And I think one of the great things that Peter
Really?
Rawlinson did was bring to Tesla automotive packaging and engineering. So even to things like the thing I remember particularly with Peter of the Model S is he was noodling at how to get the vertical height of the battery down, because that's
Right.
critical to getting the H point of the occupant low enough for the styling of the vehicle and so on, because so much of the vehicle's appearance relies on not having people sat on top of a big fat battery. So how to get the battery design down just from a mechanical perspective, what things need to appear in that vertical stack height. And I don't think that was an obsession. So electrically and in terms of battery technology, they knew everything that there was to know already in that team. But I think one of the things that Peter brought is that mechanical design obsession. So they told him what you need to have in a battery, and Peter worked out, well, how the hell am I going to get it down to the minimum possible height? And I think a lot of the success of the Model S from a styling viewpoint and so on, it was enabled by, Peter's Z height obsession with the design of the battery, for example. So I think without somebody with like Peter's experience, and I would, at that stage, I was really working on crash structures and occupant restraint and so on. So I can't claim any contribution to that side of things, but I was certainly in conversations with Peter and watching how he did it, and it was very impressive. And without that kind of experience, I don't think the powertrain technology which Tesla had available to it, I don't think it could have been deployed successfully in the Model S in the way that it was. So
That's fascinating, because that's really thinking outside the box to bring people who are not for the automotive engineering world. And again, I think it really makes a lot of sense because it was such an innovative concept to put an electric motor and battery packs to drive a car. So that was really brilliant thinking. And also, if I do remember well, and I remember Elon Musk's overzealous claims that the Model S broke the NHTSA's crash ratings, 5 stars, and all. I remember that whole debacle, but I mean, it really proved that point. That car is very sturdy, and it's the Volvo and Mercedes of the electric world in a nutshell.
Yeah, I think so. And I think one of the things a lot of people don't really understand when they think about electric vehicles, they think, okay, well, we get rid of this great big engine in the front of the vehicle typically, and now we've got all this space. So that's going to be great for safety, isn't it? But actually, it's not automatically safe for safety, because to control,
No.
for one thing, you get a lot of safety in a conventional vehicle almost for free, in a sense, in that a lot of the mass of the vehicle
True.
is that big block of the engine. The front crash structure of the vehicle doesn't have to slow that down. That's all going to hit whatever it hits and slows down. And the rest of the vehicle kind of slows down around it, almost independently of what the engine does, because the engine is so relatively heavy. Now, in an electric vehicle, you don't have that. The whole mass of the vehicle may be somewhat similar, but it's all got to be slowed down by that front crash structure. And you can't use the engine to stabilize that front crash structure. It's all got to work as a stable structure from all the different impact angles around it. So getting energy dense crash absorption structures that are stable and that are good for the whole weight of the vehicle and not just a vehicle without an engine is not trivial. So actually getting electric vehicles to work well from a crash worthiness perspective, it's not like, falling off a log. I mean, it involves some additional challenges which conventional vehicles don't have to face.
That's really fascinating what you're saying, because it's true that the engine, everything around regular conventional ICE technology is part of the structure. It's part of, well, we know how it's going to crash and everything. So I never really thought about how much you had to rework or actually start from scratch, because honestly, the best EVs out there are designed from scratch to be EVs, right?
Yes,
And that
definitely.
also
Yeah.
opens
Yeah.
up and that opens up a whole new can of worms. There are only so many handful chassis makers out there, about 5 or so at least recognized or internationally recognized. One of the things that I remember is I was test driving Ford's very first EV, which was built on a European Taurus that they had brought over here. Oh, Focus, sorry, four-door Focus that they had brought over here, and you could see that it was just putting things here and there, just making things work. And then you guys decided, hell no. And the Lotus was a great example of, okay, how do we use something that's already pretty good, but now we need to design something from scratch? So I'd love to hear your thoughts on that.
Well, I mean, I think you already summarized it very well in that sense. I mean, Ford did get involved in, of course, the Think project, which was, that plastic battery car from Scandinavia, and they did experiment with
that's right,
developing from the ground up. But it's certainly true that, I remember doing some work. One of the things we did at Lucid was adapt the Volkswagen Golf and e-Golf, use the Lucid powertrain just as it was like a weekend project and experiment. But that car probably still exists at Lucid, and I'm sure it's a lot of fun.
Hot rod. It's got to be a hot rod.
I do recall thinking there, that it was a conventional powertrain vehicle, the e-Golf, and they packed as big a battery as they could manage down the transmission tunnel, effectively, down the center of the vehicle. Very clunky packaging because the tunnel isn't designed for a battery, very limited capacity.
Exactly.
Just so many compromises. So the luxury, I mean, really the only sensible place to put a battery is underneath the vehicle. But the luxury of designing from scratch with the whole structure and the volume of the vehicle developed from the ground up with that intention in mind, just completely, I mean, ultimately, as a driver, the two things that you want, well, first of all, everybody wants great interior packaging. They want to be in a spacious interior, and they want great performance. Okay, well, the powertrain can give them the great performance. The packaging comes from hard, engineering decisions, and there's so much compromise in having a product that's designed for an ICE solution and then adapted to electric. There's just no way you're going to get that. You're either not going to have the advantage of the interior space that you should have if you're designing it well, or you're going to have a mechanically compromised, utilization compromised vehicle, which just would not be special. So I think the great thing about the Model S, I guess the Roadster, the great thing about it was just like the first time there was an electric vehicle that people didn't automatically refer to as a milk float. Although I suppose you don't have milk floats in America.
No, but I understand what you mean by that. Yes.
Yeah. Okay, but so that was exciting, but not a mass market vehicle. But the Model S really was a great vehicle to own, to operate, to drive, and it was there because it had the interior packaging of
Yes.
the opportunity that EVs give and the performance that you would previously expect from quite an exotic sports saloon. So yeah, needs to be designed from the ground up to have that.
Yeah, and you know that's funny because now that I think of it, my favorite EVs are the ones that were designed from scratch, period. And you can
Yeah.
even say to a certain extent, like even the Leaf was pretty well done for what it was. It was a very entry level kind of EV, and it did it really well for the price point.
Yeah.
I'm not sure where the chassis came from, so
Yeah, it is true. And I did meet a guy called Dave Tewig who I worked for at Byton for a while, who was
mm,
involved in the development of the Leaf. So yeah,
oh
but I
wow.
mean, there was a lot of smart people, I think, behind that project. I mean, people were learning a lot about EVs at the time, and I think they made mistakes in their battery concept and so on, which they
Yes,
wouldn't have
they
made
did.
it, didn't make a second time. But
Yes.
yeah, I mean, that's that's progress for you, I think. But a lot of the work that went into the Leaf, my understanding of it, not having been involved, was that it was, there was some high quality engineering thought that went into that vehicle.
You know, it's funny because I think off record, and it's not confirmed, so please don't quote me on it. But really, the Nissan was really rushing to the market, didn't want to go through all the certification criteria for battery packs. Air cooled was just good enough, and dump it in water, done deal. Which, yeah, you know what? Tucson in the middle of summer, 2 years later, was not a very pretty sight for these batteries. So that's yeah, that,
Learning, yeah, it's sometimes you
learning
have
the
to go
hard
through.
way.
Making the
Learning
same
the hard
mistake
way.
twice is the only unforgivable thing, isn't it? That's the
Yeah, that's the
yeah,
unforgivable thing. That's totally fine too.
yeah,
You know, you also said something really interesting about the Model S, and to me, it was the eye opener. First of all, you know, the AC propulsion e-Box was my first EV that I drove, and I was like, wow, interesting. At 50, it still has some zing. Then I jumped into a Tesla Roadster, and I thought, holy moly, this is absolutely amazing. And it's like, lager is really good. I like IPAs, but well, they're beers. It's beer in the end of the day. So white wine, red wine, whatever you want to call it. But the first time I drove a Model S, I thought, okay, that's a no-brainer. Game over, guys. This is it. You got to follow this. And I remember meeting Franz, by the way, in I think it was in 2008, maybe 2009. He had Elon's little blue roadster where you still had the gearbox. Remember that one? And
yeah,
he said something really interesting because you guys were working on the White Star at that point. It wasn't called the Model S. And he said, Nicholas, you don't know how exciting it is, and right to what you were saying before, to design a car without taking into account an opposing piston engine, a gasoline
yeah,
tank, and all of that, to design it from scratch. And
yeah.
he was in heaven seven, in seventh heaven. So it was really good, and that came through. And to this day, I think the ones who really do a darn good job at interior designing are the Chinese. Ever been in a Neo? Ever been in an Xpeng? They have that
Yeah,
spaciousness
yeah,
feel
yeah,
to them because that's what they want. Whereas over here, we're
yeah,
like, yeah, whatever. But yeah,
yeah.
I think
It's
that's a
true.
very good
It's
point.
true. I think in passing there, one thing I would say is if somebody ever makes a family tree of how EVs ever came about, I hope that there is an honoured component for AC propulsion, an honoured box, because
Yes.
I think secretly, like half of the electric motors in the first generation of Western EVs were all copies. Or, I'm sure if you went
Absolutely.
back to the engineering drawings, they were under the Tipex, their AC propulsion would be on there.
So
So
I was very close to the AC propulsion team, especially around the Roadster 1.5 debacle. I will let people figure that one out. We're not going to go into those debates, but I was very close to them, and I wanted to set the record straight, which then, by the way, made me a Tesla hater. And I'm like, I'm not a Tesla hater. I love Tesla cars. What is wrong with you? But I did write a whole series or a whole article on Clean Technica about the T0, which really is the impetus to these modern EVs that we have, and right down to the whole story around it. The chassis maker was from Burbank, and these guys just, wanted to have fun with electric motors and controllers and all that good stuff, that it behooves them to change the lead acid batteries to lithium because it was a little too light, to be honest. And I thought, wow, what a concept it is to have something like that.
yeah,
Um, And you said something also earlier. You're right about EVs. The one thing that so my background is Bugattis, 1930s Alfa Romeos. This is what I grew up with. It was really hard to wrap my head around an electric motor, but then once I understood, for me was the efficiency. One third of your gasoline tank ends up moving your car or pushing your car forward. Two thirds is lost in heat and friction. That's not efficient. But an electric motor, electric car, 80 to 90%. Okay, I can wrap my head around that. And you're right about the ecological aspect of it. I remember back then in 2008 seeing people with solar panels on their roofs, and they had already broken even with it, and they are starting to look for battery packs to charge their EVs later on and everything. And I was like, wow, that just makes perfect sense to me. So
Yeah,
I agree with that. That's that the ecosystem makes a
yeah.
heck of a lot of sense, whether it's efficiency, performance, your environmental concerns. It's a no-brainer, especially when you look at the Lucid Air with 500 miles.
Yeah,
Yes.
I think on the ecology thing as well, there used to be a lot of talk, probably less now, about the idea of peak oil and the actual availability of the resource. But it's not that at all for me. It's what it's like to live in cities, and we're an increasingly urbanizing society. And if you have all these inefficient little thermal engines running around pumping out pollutants in the cities become disgusting places to live. And I remember I had significant part of my team during one of my jobs was based in Nanjing in China. And I remember the first weekend I was there, I climbed up to the top of some little hill there, thinking it would be nice to look out over the city. And in the city, you don't really know what you're breathing. But when you get up above and you look down at this kind of greenish grey soup that the whole city is bathed in, you realize that is no way to live. And I was recalling this, I think last February I was in El Salvador for a friend's wedding, and we were walking along some street in San Salvador, and you become increasingly conscious of it. It's like, in the UK people used to smoke in pubs, and you
That's
just
right.
never thought about it. And now you don't
Yeah.
anymore. And now if somebody's smoking near me, I'm really aware of it. And it's the same now if I'm in a place where there's a lot of ICE engine pollution. I'm really aware of it. And I was walking
Yep.
through San Salvador and thinking, this is not a nice way to live, you know, just from the point of view of atmospheric pollution. And that, I think, is the killer issue. It's to get those pollution sources away from the places where people live and work. And it makes a huge difference. And the more that I can help that to happen, the more I think livable this future urbanized world is going to be. So that's a real motivator for me. So,
Yeah, no, I think you're right because I mean, I remember landing in Los Angeles in the 80s, and you would go through that soup, that gray smog soup, and then you were in it. And you're right, once you were under it, you didn't remember it. But as soon as you climbed up the mountains again, you're like, wow.
yeah,
And same thing when I went to Guangzhou, Shenzhen, Beijing, Shanghai, same thing. There was the same soup that you land in there. And you're right, it's not a it's not a good way to fly,
it's
which
not.
is really funny because my Chinese friends used to say, "Oh, it's dusty today." I was like, there's no dust here. What are you talking about? I was like, okay, whatever.
Yeah,
But that needs to change. And that's right,
yeah.
especially in very condensed places like that, electric motors. And that's the point I wanted to get to right now. I never understood, and it's gotten better over the decades, but the goalposts for conventional cars and electric cars are always so different, right? People want a 500, 1,000 mile range electric car, but they have no idea how much range to get out of their gasoline engine, let alone that only one third of their gasoline tank, propels the car. And I never understood this dichotomy where one is like this, one is like that. And it's like, look,
Yeah.
you've got a perfect trio right here: performance, efficiency, and it's also, well, it's clean. Come on, what is wrong there? Don't
I,
tell me about this Obama car thingy. What the heck? What are you thinking here?
that is absolutely true. I mean, the car. We've got two electric cars in our family. My wife has an electric car. I've got one. I didn't impose that. That was a in terms of my wife's car. She didn't wish to be left behind. But both of these cars, one of them has a nominal range of 200, maybe it's practically just over 200 miles, and then my car range is maybe 330 miles.
Right.
We drive anywhere. We drive to France. We drive to the north of Scotland, and even with the level of charging infrastructure that we have at the moment, with the current level of utilisation, there's nowhere in the UK or mainland Europe that I would ever wish to drive to where I would feel there's a limitation from having the electric car as my sole sort of personal transport device. So to me, the solution, there's no more range needed. I mean, maybe some special cases want more range, and maybe people want it for whatever reasons. Because customers are always right in that sense. But from my use case, I don't need any more range, and I can go absolutely anywhere I want. I can recharge at an acceptable speed. There is no, for my use case, there's no more problem to solve. I just want it to be prettier and cheaper and whatever.
Yes, of course, more affordable. And that is such a great point you've made here. The difference between European business case and the American business case, whereas you guys already off the bat, you're using 220, 240. You can actually recharge overnight most EVs these days. I'm not talking about the biggest Lucid or Model S's, but that's something you can do. You have shorter distances. So that makes a lot of sense. However, over here, it's true that the distances are different, but you know what, Savannah to Atlanta, I can have an electric car and drive there, and along the way I can recharge. That's totally fine. The one thing I think that kills it over here is, short of the infrastructure being okay, it's developing really well, it's how many people drive. You have a lot of salespeople, you have a lot of solopreneurs, you have a lot of people who are on the road. So I talked to, by the way, a week ago, I see this beautiful Lucid Air in the middle of Savannah. And of course, I'll engage anyone with an EV. And this guy is a lawyer. And I asked him, I said, why did you get that? He goes, well, I had a Model 3, but it's true that after driving, I don't know, maybe 100,000 of miles a year, the battery went down a bit. And that's understandable because he was supercharging it all the time, right? So, of course, the battery took a big dent. But he got the Lucid, and he got the top line, of course, with a 500 plus mile range. And he says, this is amazing. I can drive to Atlanta and not have to worry about that. And I think it's about 300 and some odd miles. But this is a guy who needs his car. He needs his car. He cannot be late to defend someone. And you're right, for all. So the only reason why we were going to get a Model 3 last year, but I don't know if you remember, that was at the time where the new administration was here. Let's just say that Musk did not have the best public image at the time. And we were like, do we get a Model 3 and fear having somebody scratch it or put something on the car, whatever. So we opted against it. And I still regret it to this day, because we have a 240 outlet in the garage right here, and so there you go. I think over here it's getting better. The charging stations are better, the network is getting better, but it might make still more sense in Europe, where your distances are slightly better too at the same time. So I understand both.
I mean, there's an element to that. I mean, there are use cases. I'm sure there's quite legitimately use cases in the UK that would find it less convenient. For my use case, there's already not a problem. I think one of the interesting things about charging speeds is we think a lot of it is about, like, for example, the battery voltage in the vehicle or the power at the outlet or whatever. If those things impose a limitation, then that is a problem. Ultimately, the thing that determines the rate at which you can charge the battery is the physical construction and chemistry of the cell. And it doesn't matter whether you arrange the cells into a 900 volt battery or a 450 volt battery. The limiting factor to how fast you can, if you're talking about DC fast charging, is the capability of the cell. And so I think a lot of the mechanisms required to unlock high performance charging is really in terms of chemical and physical structure evolution in the cell. And, the chargers will follow along as they must, but you can't charge a car more quickly by, for example, putting in a 900 volt battery.
Nope.
You've got to have the right cell to do that. That's interesting to see how that's developing over time. And there's a lot of always talk about this next generation of battery that's going to have this range or that. But if you look at the conventional C rates, the charging rates that can be supported by, for example, a standard lithium ion, they're going up all the time.
They go up all the time.
Yeah. So even without radical changes to technology, there's just the incremental improvements over time.
Yes.
So I mean, so my car, for example, even if I've depleted it as far down as I would ever practically deplete it on a journey, and I really need a fast charge, I never have to. I can't get a cup of coffee and go to the toilet faster than my car can charge.
There you go.
Yeah.
There you go. That's a good metric right there. But yeah, you're right, because when I think about it, how many different chemistries or exotic chemistries we have heard about ever since we started working on all these cars? Well, there was lithium air, lithium metal, lithium sulfur, lithium this, lithium that, phosphates, which work really well, by the way. Phosphates, I really understand that. But in the end, where has all the work gone? Well, good old lithium ion, right? And the charging rates have been better and better. And it's also a good case is that you don't always need the best and the greatest and whatever, but you need to use it efficiently, have a good management system, and
Yeah.
that's where you make the incremental changes that win over people in the long run.
Yeah.
And just like my cell phone, I charge it wherever I find a plug. It's not a
Yeah.
stress.
Yeah.
Just do it.
Yeah.
So
actually,
stressful.
One of the things that's also struck me is, as well, when we talk about EV manufacturers, how good the Chinese EV industry is now at developing battery management systems, and so on. Really, it's funny. I had some reason to read the DTC codes on my car yesterday, which has a Chinese battery in it, and I was reading, like DTC codes from the motors and the VCUs and so on, and it was like 13, 23, whatever, accumulated over the last year, and I got down to the battery and it was 0. And I think actually we sometimes in the West and it's often Chinese vehicles are thought to be a threat, in the sense that if they get good enough, they'll be hard to challenge. But when you actually look at the engineering quality that already exists in some of those vehicles, it is very impressive. These people are not a developing automotive sector. They damn well know what they're doing, and they do a good job.
I think I've had that conversation so many times, even publicly, is, stop thinking that the Chinese only produce bad quality, but it's the other way around. It's the West asks another country to produce cheap goods. So of course you have that because you want more affordable. It's you that drives that. But remember that these guys have 2, 3, 4, 5,000-year-old vases still doing really well, buried under tons of soil to this day, right? And ancient temples and things that didn't even exist, that you didn't exist when that was made. So yeah, no, I agree. One car that really surprised me was when I was working with Xpeng. So of course I had gone in the G4. Okay, here, let's use that for an example. 2019, we're in Shanghai, and was it Shanghai? No, sorry, it was in Guangzhou. We're in Guangzhou, and we're in the G4, and we're going to this special place, and it's just 4 of us in a car, 2 of our Xpeng friends, and myself and another journalist. And we have to go park, but it's a really tight spot. So the guy said, "Hey, get out of the car. We won't be able to open the doors." But he also gets out and closes the doors, and he goes click, and the car parked itself.
Yeah.
2019, right? Hello.
Yeah.
Then yeah. I got behind the wheels of a XP7 or P7, sorry. And I gotta tell you, I know the whole story about that car. It's a beautiful car. The price point is excellent. I know you guys have it in Europe. So are Chinese cars a threat? Yes, they've been a threat for a long time. And you know why? Because they're doing exactly what people have been asking the Western automotive industries to do: more affordable, more reliable, just better interiors. Go inside and take a ride in a Neo car in China. It's really plush. It feels good. It's spacious. It's great. So understandably so. And I think if you have to boil it down, basically, is you have in the West, you have these quarterly profit people who cannot think years ahead. And then you have, the Asian counterparts who think 5, 10, 15, 50 years ahead. Hard to go up against that. So yeah, they figured it out. They saw it and they were like, well, what do we want to be in 50 years? You can't compete with that.
Well, so I think you can. But you got to understand that you can't just say you can't just hide behind a tariff barrier. You can't pretend that it's not driven by competence and technology. You've actually got to have the humility and the reflective character to learn from what's good about what they're doing and fuse it with the best of the traditions of Western engineering. But I think having a bit of humility about how they're achieving the success they're achieving, I think would be really helpful for the Western automotive sector.
Yes. Yeah. And I think there is that time where it just, we need to stop. We need to, a business model has to evolve, right? Every 3, 6 months, you have to look at it again. You have to change it. You have to do all these things. And all right, so that's the competition. Great. What can we do better? Like you said, what can we do? And we can. Obviously, we can do better. You brought up another story I had forgotten about when you were talking about how, Peter was trying to get the battery as far low down as possible, which of course in an EV means a much lower center of gravity. I was talking to a team that never gets enough credit, and it's probably going to make most people smile, but it was the Chrysler team that was working on the original EVs, and it was called the Envy team, ENVI team. I had such a blast talking to these guys because I thought of all the people I could have a good conversations about EV. Chrysler was never, first and foremost in my mind. However, and we're really going back into the ancient history of modern EVs here. But at the time when Tesla was working on the Lotus, and it went through a lot of iterations of changing the sills and everything of the Lotus EV, the Lotus Elise, I think at the time. Well, Chrysler was doing the same thing, but Chrysler didn't have the luxury of reworking anything, so they just put a slightly more powerful motor. And those two cars, by the way, were equally matched. And there was another third one that was also a two-door coupe roadster, and that was the Monegasque people from Monaco. The Fetiche was also. All these three cars were battling together. All of them had the same problem, how to keep that battery down. So I spoke to the Envy team leader, and he said something I'll always remember. He said, ultimately, this is a 500 Abarth, right? And I managed to shove in that battery pack and only take half an inch inside the cabin. Think about that.
Yeah.
Brilliant.
And actually, that comes back to an earlier thing that you said. It's very hard to do if you're adapting, right?
Yep.
Much easier to do if you're doing it from scratch. But one of the things that I really impressed me about the way Peter works is that even then, it doesn't happen by accident. Because if you give a designer or a group of engineers all this space, they will, by instinct, lazily fill it by distributing bits around the whole space. If you want to really make the most of it by obsessively improving on the packaging of the components that you do have in there, you need somebody, I nearly said somebody psychopathic, and I don't want Peter to hear that. I don't. So I'm going to back away from that. But
I think Peter knows. He's all right with that.
Yeah. And that was, he was a CTO at that time at Lucid, and he would go around everybody's desk and look over their shoulder, and he would give them a hell of a roasting, if there was any spare volume. But if something didn't look structurally sensible, and if it was just smaller than it needed to be for its structural purpose, he was equally hot on that. So you needed every bit of space you needed to make something robust, and nothing else, and his packaging obsession was just baked into the way Lucid, and I probably still is today, but certainly back then it was absolutely central to the way that Peter ran the engineering of the Lucid Air, and very impressive to watch.
It was very impressive because I think the first time we met, you and I, was at it was at the Peterson Museum at the release of the Lucid Air in 2017. I'll always remember what he said. And I even asked him, I said, do you mind by going public by saying this? And he goes, absolutely. I was like, I like this guy. He is really straightforward. But he said, Nicolas, this is a car I sculpted every angle, every inches of it to where the battery could go, where everything could go. This is something I couldn't do at Tesla. And that's why
Yeah.
I said, are you sure you want to say that? And he goes, oh, absolutely. And I was like, man, I like this guy. But yeah, it came through.
Yeah.
That part really came through. I was like, he must be the hardest boss to have on your back, because it would be like, no, you can do better here.
Yeah. If for some reason he didn't like you, it was a miserable place to be. But that comment about his sculpting it all is not hyperbole at all. It's absolutely true, and he really did. And if you were sort of critiquing things that went well and things that didn't go well, the bit I think that was less successful was on the software side, and that's because there's a whole new area of technology required. And actually, even big EV companies, Volkswagens and the like, find it very difficult to manage that transition to that hyper integrated, distributed sort of software machine that these vehicles have begun. Actually, that whole process for developing software at that level of complexity is not mature in the automotive sector. Usually that's been, traditionally, it's been subsystem by subsystem, supplier by supplier, limited intercommunication. And now to do that actually at a vehicle level, integrating inputs from all over these different components, it's just very hard to do. And I don't think it's obviously much better now at Lucid than it was when I was there, but I don't think we were that mature or sophisticated about that, unfortunately. And
you're right. You know what? The crown goes to Tesla. When you think about that ecosystem inside the UI, everything, the integration with technology, nobody does it better than Tesla to this day, at least none that I can think of, because even this guy who bought his new Lucid Air and spent, quite a pretty penny on it too. He says, the Bluetooth kicks out once in a while and all that kind of stuff. And it's like, you're right. You're totally right. And that you need for that, this is where Silicon Valley comes in really. And this is something too, is I really enjoyed what was happening at Byton at the time. It almost had like the right recipe for success. And I know we can definitely say something shouldn't have happened, but the one thing that I did like was, Abe Chan, for instance, he was perfect for his role because he understood that, lock yourself in a car trunk and free yourself with a cell phone. This guy's going to figure it out. Because he doesn't have that automotive engineering background, and that's just like same thing with you in your case. And I almost felt like Byton was almost a prototype of how to do it right. And still yet, there are plenty of ways you can fail, obviously, and sometimes a little beyond our hopes.
Yeah. That's a knife to my heart, that the loss of Byton, really. Because I think that was a great product. I mean,
it was.
I love the team. I love the integration of the Chinese side of it with the Santa Clara side of it as well. I thought that was great. And I think from a technical perspective, the project really had legs. And I think
it deserved to live. And I'm really upset. I'm very sad. And what was even funny is because I met Benoit Jacob even before, when he was designing the i3 and the i8, and I'm French, right? So of course I'm listening to this guy with his really thick French accent, and I'm like, "Tu parles français?" And then we started exploded in French, right? But he won me over, and I can't remember if it was 2011, 2000, somewhere around there. He was at the LA Auto Show, and he was right in front of the i3 and the i8, and I was like, "Okay, so tell me a little bit about that," because I've been watching the whole concept to this. And he goes, the one thing I wanted to do here that nobody else does is that in 50 years, I want these cars to be able to work. I don't want any pneumatic, electric, anything whatsoever. This is a wind tunnel, almost perfection. And I thought, wow, this guy really gets it. So then I saw that he went to Byton, then I saw you were there. So everybody was there. I was like, yeah, this is it. This is really it. Oh, and what was the name of the next Byton, the sedan that was so beautiful? I was like, this is it. This is what I wanted.
So I don't think we should try to recall the names, because I think the names are the weakest point. So I think it was the M Byte and the was the SUV, and then was it the?
It was wrong. You're right. Yeah, these names were not they weren't well thought out. But that sedan was drop dead gorgeous.
That was very pretty, very pretty. Yeah,
that's what I wanted.
I think they were well engineered.
Yeah. Absolutely.
There would have been problems if they'd been in production. There would have been issues, I know, but the product was great. It was lovely to drive. It was. well
What
thought through.
car do you know of that came out, the very first one from the very first company that didn't have a problem? I mean,
Yeah,
that's just,
exactly,
I think
exactly.
people these days accept,
Yeah,
people want way more, and it's like, well, you still have to be a little bit patient. You know, the one actually EV I'm looking forward to, if Hyundai really does it, that EV4, I think it's the EV4, the sedan, the prototype that they have right now, that's gorgeous. That I'm like, okay, finally, because I want a sedan. I don't want an SUV. I don't want a pickup truck. I don't want a big car. I want a regular small car, just enough for my two Labradors behind, and that's about it. But that EV4 looks really good to me.
I think so. I really think the Hyundai Kia have got some very competent engineering going on, and not
I do
flashy,
too.
but just solid, really.
Perfect.
And my
Yeah.
brother-in-law is a Kia EV driver and has had no trouble at all, and it's a great little car.
Do you know it's what Toyota Honda were in the 80s, I think, in many ways. And funny enough, because if you remember Hyundai and Kia in the 90s, it was horrible. Nobody wanted to drive those things. They were not well made and everything. But then they did the smart thing. They went to Japan and they got these engineers to come across. And all of a sudden, these cars became really, really good. The first time I did not have range anxiety, as they used to call it back then. What a horrible term. Was driving the Kia Soul because it had a
Yeah.
90 kilowatt hour battery pack and I could go 2 days driving without recharging. And I was like, that's it. And I met them and I thought these guys are onto something. They're really smart about it. They're pragmatic. And I've had James Bell on the call here, as an old friend of mine, and we talked a little bit more about what they're doing. And it's pretty darn pragmatic. And of course, I'm right next to the Hyundai plant right here. I've got another friend of ours who, you remember Ian Clark? He used to work with you guys at Lucid, and I knew him from way, way, way back then in the Coda days.
Oh
I'm going to
yeah.
get him on the podcast because I want to. Coda was also a great car company. I was really sad that really the look of the car is why it doesn't work for you. What a shame. It was a good car, a good daily driver.
I think so.
Too early.
Yeah. I mean, and there's this thing that obviously there's this kind of explosion of people trying to find spaces of opportunity with EVs, and of course there are, and many of them are not going to succeed because that's the price of progress. But when you look at the individual bits of each of these cars, even the ones that don't succeed, engineers who were involved in them go on to other companies
Yes.
and take those ideas with them, or people just observe them and pick up the bits that they like or feel that there's a logic for, and so on. So a lot of this stuff, we talk about companies that, like fell by the wayside, but the ideas
Yeah.
don't fall by the wayside. The ones that have
No.
legs
No.
continue, And so
Well,
even Byton, the sort of coast to coast screen, which, people used to take the mickey out of at the time, but now we see that the actual integration of information and infotainment and so on across the width of the front of the car is becoming, like a mainstream technology. And more elegantly, I mean, in Byton it was just this big long rectangular thing, but now it's sculpted into the fascia
yep.
effectively. I think
I think
the
you're
environment
right.
is good.
Byton pushed the envelope in many ways, and it's true. I remember when people were writing about that gimmick, who needs this, who needs that. Then I sat in it and I thought, whoa, talk about, I have a big Acer like this, and I can do so many things with that instead of a square little monitor. And I thought it was brilliant. And I think, well, that's one thing I should do. I need to get some Byton people on the podcast and talk about all of this and see what do you want. And you're right. How many people have gone on to their second, third, fourth, fifth EV companies, right? And still moving on. And I've seen people move over to the advanced air mobility side of things, which is even more interesting. And you know what? I just realized that we've been recording for 15 minutes and I haven't even gotten to asking you the more personal questions, which is really interesting, which, by the way, means that you need to come back, young man. You need to come back because we barely scratched the surface. Just that I knew that was going to happen, but I did want to talk a little bit about the personal aspect of it. I mean, what gets you out of bed in the morning? Why not continue to be a physicist somewhere else and just call it a day?
So, I mean, first of all, all engineers we're technology nerds, we love solving problems. And, I can get a lot of pleasure out of, I help out now repairing bikes at our local refugee centre. I get a lot of pleasure out of that, working out how this free hub was assembled and what's gone wrong with it and what. So we just problems are interesting, aren't they? They motivate you, and so I enjoy that. But I do think that there is an important mission. Sounds too pompous, but I think there's an important challenge for society in how do we live well in a resource-constrained world where things like pollution and traffic congestion and so on affect the quality of life and the way, and that affects human well-being at a psychological level and at a physical level. And I think how do we live well as people? This is a fundamental challenge, I think, for engineering, not just transportation, across all the aspects of our lives, but transportation is the bit that I'm involved in. And I think, having a part of that story, there's been in my working life, I've had this huge privilege of being involved in two transformative revolutions in transport. So the first was the vehicle safety. And when I look at the rate of road traffic deaths in the UK back in the early, say, 90s, and how by attention to crashworthiness design, to occupant restraints, to public perception through the introduction of NCAP testing and so on, that number of deaths has fallen off a cliff. That's probably the bad analogy, isn't it, really?
But apropos, right?
Yeah. And so having been part of that, engineering revolution, that's made a huge difference to the experience of life on the roads, well, of Britain in my case, but globally, worldwide. And I was very happy privilege of being involved in that from the point of view of both the engineering development and the legislative development. And then to have a second bite at that cherry with green transportation and to be at the heart of electric powertrain development and so on, that has been such a privilege. And then on the edge of advanced driver assistance and autonomous driving as well.
Yes.
I feel I've just, through no wisdom of my own, have stumbled into the room at the right time, twice, 2.5 times. So that's taught me to keep stumbling into rooms, because you never know, there might be a third and I might be there.
You know what I'm thinking, right? I said, you need to come into advanced air mobility. I need to have your expertise into that realm. But you know what? We're at the end of this show, which means I'm so sorry. Now you have to come back. But I'd love to schedule a follow-up in about a month or so to continue this and to see how you see the industry moving forward. I think you've answered some of it when it comes to the EV side of things, but there's also, one of the potentials of advanced air mobility is it's not just aviation, but it's actually starting to connect the dots between where cars can't go, where helicopters can't go, where boats can't go, where trains can't go. And it's starting to get into that last few miles niche pocket of enabling, for now, of course, a few people to go from, a vertiport to a train station to a boat, whatever. So I'd love to get your point of view on all of that, because we're at the very first steps. Think of it this way. We are at the Mitsubishi i-MiEV step of where we were right now, where we were back then with advanced air mobility, just to give you something to think about.
Okay, I'll look forward to the invite then, Nicolas. Thank you very much.
David, thank you so much for being here with us today. It really means a lot to me, and I really look forward to our next conversation. It's always been wonderful talking to you. I've always learned a heck of a lot, and yes, today is no exception. So I hope you have a wonderful rest of the day, and I really look forward to talking to you again in about a month or so.
Thank you very much. I look forward to that too. Cheers, Nicolas.
Cheers. Thank you. Bye-bye.
Bye.